There are no instructions, no rule book, and you can't see the boundaries of the playing field. You make moves, try things, sometimes win, sometimes lose, but something invisible seems to push back when you try to cheat. That invisible push is exactly what I mean when I talk about the universe's rules. These are the rules you can't break, no matter how clever, strong, or lucky you think you are. They are not suggestions or opinions. They are the underlying patterns that make reality what it is. Think about gravity for a second. You drop an apple and it falls. You can yell at it, wish it away, or try to argue with it, but it doesn't care. The apple falls because the universe has a rule that objects attract each other. This is one of the simplest examples, but it hints at a bigger idea. There are patterns in the universe that are absolute. Once we discover them, we can rely on them completely. Gravity is not unique in this way. There are other fundamental rules that shape every motion, every collision, every flicker of energy. One is the conservation of energy, which simply means that energy cannot be created from nothing or destroyed into nothing. It can change forms, like when chemical energy in gasoline turns into motion in a car, or when sunlight turns into electricity in a solar panel. But the total amount of energy remains constant. Another is the conservation of momentum. If two ice skaters push off each other, the total momentum before and after their push is exactly the same. No cheating allowed. Then there's the universal speed limit. Nothing can travel faster than light. This isn't just a suggestion, it's a fundamental boundary that affects everything from how fast information can move to how time itself works. What's remarkable is how these rules are hidden in plain sight. You don't need to go to a laboratory to experience them. You feel them in every step you take, every object you drop, every car you see driving down the street. The universe is like a giant game board, and we're all moving on it, learning the rules by bumping into walls we can't see at first. Some of the rules are obvious, like gravity. Others, like the rules of quantum mechanics, are strange and counterintuitive, but no less real. A particle can be in multiple places at once. Light can behave as both a wave and a particle. And yet, even in these weird cases, the universe doesn't break its own rules. Everything follows a consistent pattern, even if that pattern defies our everyday intuition. The more we study, the more these patterns appear not as arbitrary quirks, but as a coherent framework. And that's what makes the universe so fascinating. We live in a world that is predictable in the right way, complex enough to surprise us, but consistent enough that we can explore it, measure it, and understand it piece by piece. And the deeper we go, the stranger and more beautiful these rules become, revealing a reality that is far more structured and elegant than we might have guessed from our ordinary experience. To truly understand these secret rules, it helps to imagine them through everyday experiences and thought experiments. Let's start with something simple. Imagine you're in a completely dark room. You can't see the walls or the furniture, but as you walk around, eventually you bump into something. At first, you might stumble or get frustrated, but slowly you begin to map the space in your mind. You learn where the walls are, where the floor rises, and where obstacles appear. This is similar to how humans discover the universe's rules. At first, everything seems mysterious, chaotic, and even random. But through observation, experiment, and careful measurement, we start to feel the invisible walls of reality. Gravity, energy, motion, light, all these forces are like the unseen edges of that dark room. We can't break them. We can't jump over them or step through them. We can only explore them and learn how to move within them. Now imagine a sandbox. You're building a sandcastle, and the grains of sand obey the rules of gravity and friction. You can pile them into towers, dig moats, and sculpt walls. But if you try to make a perfectly vertical tower, eventually it collapses. No matter how carefully you stack the grains, the tower will obey the basic rules of physics. In the same way, the universe sets limits on what is possible. At the scale of tiny particles, these rules can seem even stranger. Electrons don't orbit like planets. They exist in clouds of probability. Particles can be in multiple states at once, yet even here, they follow consistent patterns. The universe never breaks its own rules, no matter how strange those rules might seem to us. Now, consider a highway with a speed limit. Light is like a car on this cosmic road, traveling at 792 kilometers per second. No matter what you do, you can't go faster. This speed limit isn't arbitrary. It shapes how time and space behave, how information travels. and even how cause and effect work. Imagine trying to outrun a beam of light. No matter how fast you accelerate, the light still moves away from you at the same speed. This seems counterintuitive, but it's one of the universe's fundamental rules. Everything we do, from GPS signals to the light from distant stars, obeys this limit. We might not feel it in our everyday lives, but it underpins the entire structure of reality. These analogies also reveal why the universe's rules feel so strange at first. They are not designed for human intuition. Our brains evolved to survive in a world of apples, rivers, and fires, not subatomic particles or galaxies moving at relativistic speeds. Yet with observation, thought experiments, and mathematics as our tool set, we extend our senses. We discover the hidden structure behind what seems random. Each law, each pattern, each unbreakable rule is like a door opening into a deeper understanding of reality, showing us that even in the weirdest corners of the universe, there is order. And in learning that order, we find a kind of beauty that is not invented, not imagined, but real, a structure that holds the entire cosmos together. Once we start to see these unbreakable rules in action, the next question naturally arises. What do we actually know, and what remains a mystery? On the surface, it seems like humans have uncovered almost everything. We can send rockets to other planets, predict eclipses centuries in advance, and manipulate atoms to create new materials. We understand the basics of motion, energy, and forces. Gravity pulls, electromagnetism binds, and particles interact in ways we can describe with astonishing precision. We know that the universe follows patterns everywhere. An atom in your hand behaves the same as an atom in a star a million light years away. That consistency is what allows science to exist at all. If the rules change from place to place, if energy or momentum weren't conserved, we would be lost in chaos, unable to make sense of anything. But even though we know a lot, there is a profound amount we still do not understand. At the very small scale of quantum mechanics, the universe behaves in ways that defy everyday logic. Particles can exist in multiple states simultaneously. Measuring them seems to affect their behavior. Probabilities, not certainties, govern the tiniest building blocks of matter. Then there's gravity, which works beautifully at the scale of planets, stars, and galaxies, but stubbornly refuses to fit neatly into quantum mechanics. Reconciling these two pillars of physics remains one of the greatest challenges in science. Even the largest scales of the universe hold mysteries. We can see galaxies speeding away from each other, and we know that the universe is expanding. But what is dark energy, this invisible force driving that expansion? What is dark matter, the unseen mass that shapes galaxies, yet refuses to reveal itself directly? And what happened in the first moments of the universe, when the normal rules of space and time may have broken down entirely? These are questions we can observe but cannot fully explain. They are like the edges of the cosmic map, where the territory fades into unknown territory. Part of the difficulty comes from the limits of human perception and cognition. Our brains evolved to survive in a world of objects moving at ordinary speeds, where cause and effect follow intuitive paths. We did not evolve to grasp scales a trillion times smaller than a grain of sand or distances billions of light years across. We do not naturally understand time dilation, quantum superposition, or the subtle curvature of space-time. To make sense of these things, we must rely on abstract mathematics, thought experiments, and precise instruments that extend our senses far beyond what nature intended. Yet, even with all these limitations, humans have been remarkably successful at uncovering the universe's rules. We may not know why the rules exist, or why they take the form they do, but we can describe their consequences with incredible accuracy. That consistency, that structure, is astonishing in itself. The universe is not chaotic in its foundation. It obeys patterns that can be discovered, tested, and understood, even when they challenge every instinct we have about how reality should behave. In this tension between what we know and what we don't, we find the true wonder of physics, a glimpse of reality that is orderly yet endlessly mysterious, familiar yet profoundly strange. Even after centuries of observations, calculation, and experiment, humans still struggle to fully understand the universe's rules, and the reasons are deeper than mere ignorance. Part of it is cognitive. Our brains evolved for survival, not for comprehending the cosmos. They are perfectly designed to judge distance when climbing a tree, track the motion of animals, and recognize patterns in our social environment. But the universe operates on scales and in ways that our intuition was never prepared to handle. A single particle can exist in multiple places at once. Space can stretch faster than light. Time can slow down or speed up depending on motion and gravity. These concepts are alien to the everyday world, and trying to visualize them often leads to confusion or paradoxes. We rely on abstract mathematics to extend our minds beyond what our senses can grasp. But even then, the deeper we go, the less the universe resembles the reality we experience directly. Another reason we struggle is that some rules are truly fundamental. They are not derived from simpler principles. They are the bedrock itself. Conservation laws, the speed of light, the uncertainty principle. These are the foundation stones on which the universe is built. You cannot step outside them, no matter how ingenious a theory you imagine. We can describe what they do, predict their consequences, and observe their effects, but we cannot explain why they exist in any ultimate sense. They are simply there, and the universe follows them faithfully. It's like trying to understand why the floor supports you. You can measure its strength, test it, even predict what happens if you jump, but the fact that it exists is a given. Scale also complicates our understanding. The rules of the universe appear different depending on how closely or broadly we look. The motions of planets and stars seem smooth and predictable, yet the tiniest particles obey probabilities instead of certainties. Gravity dominates the large scale, while quantum effects dominate the small scale. Combining these two into a single, consistent picture is a task that has confounded the greatest minds in physics for over a century. Black holes, the early universe, and the edges of space-time are places where our rules stretch to the breaking point, where intuition fails completely. Part of the struggle is also conceptual. Humans like stories, causes, and familiar narratives. We want to know the reason why, the mechanism behind every effect. But the universe often refuses to provide satisfying narratives. Quantum mechanics does not give a story of an electron moving along a path. General relativity does not tell a story about why space-time curves. It only tells you how it does. We must learn to accept a different kind of understanding, precise, predictive, and consistent, but often counterintuitive. Learning to see reality this way is like learning a new language, one that speaks in mathematics, probabilities, and fields instead of words and common sense. And yet, despite these struggles, we have been remarkably successful. Humans have built machines that reach the edges of the solar system, harnessed energy from distant stars, and glimpsed the first light of the universe. We may never fully grasp why the rules exist or see them with our eyes alone, but we can know their effects and navigate reality with astonishing accuracy. The struggle itself is a reflection of how remarkable these rules are, invisible, unbreakable, and yet precise enough that we can learn them at all. In that struggle, we come face to face with the universe as it is, not as we wish it to be, and that confrontation changes the way we see everything, from the smallest atom in our hand to the largest galaxy in the night sky. When we step back and look at the universe as a whole, a remarkable pattern emerges. The rules we've been exploring are not just arbitrary limits. They are the framework that allows everything to exist at all. Stars can shine, planets can form, oceans can flow, and life can emerge only because these rules are consistent and unbreakable. The universe doesn't need to accommodate us. It doesn't adjust itself to our understanding or desires. Yet, despite this indifference, the rules are elegant enough that we can discover them, understand them, and even use them to shape our own experience. There's a profound beauty in that. We live in a world that is precise enough to be predictable, yet vast and complex enough to surprise us endlessly. Understanding these rules also reshapes how we see ourselves. We are not separate from the universe. We are participants in its structure. Every movement we make, every action we take, every thought that arises in our minds is governed by the same fundamental principles that guide distant galaxies. The atoms in our bodies obey quantum mechanics. The light we see obeys the speed limit of the cosmos. Even our energy, the fuel for thought and motion, obeys the unbreakable law of conservation. In a sense, we are not just observers of the universe. We are expressions of its rules, momentary patterns in an immense, unfolding system. Yet there is humility in this understanding. The more we know, the more we realize how much we do not know. There are edges to our comprehension where the rules themselves seem mysterious, where black holes swallow space and time, and where the universe begins in ways we cannot yet visualize. We live on the boundary between the known and the unknown, and that boundary keeps receding the further we explore. This is not failure. It is the nature of discovery. The universe does not surrender its secrets easily, and perhaps it never will. And in that challenge lies the essence of science: curiosity without guarantee, understanding without certainty, insight without arrogance. This perspective changes how we see reality itself. We begin to appreciate that the universe is not chaotic or random at its core. It is structured, governed, and beautifully consistent. Even when reality seems strange or counterintuitive, there is a deep order beneath the surface. Our task is not to bend the universe to our will or to find easy explanations, but to learn its language, to recognize the patterns, and to see how every law and principle interlocks with the next. The rules are unbreakable, but understanding them gives us freedom, the freedom to predict, to innovate, to marvel, and to participate in the unfolding story of reality. Ultimately, the universe's secret rules are a reminder of something profound. Existence itself is not accidental. The patterns we discover are not just constraints, they are the canvas on which everything happens. They are invisible, unyielding, and eternal, yet they allow creativity, life, and consciousness to flourish. Recognizing this gives a new perspective on our place in the cosmos. We are not masters of the universe, but we are its witnesses, explorers, and participants. And in embracing the unbreakable rules of reality, we find a kind of wonder that is deeper than magic, more lasting than myth, and richer than imagination alone. A scientific awe that transforms how we perceive everything around us, from the smallest particle to the farthest star. Even after understanding the universe's rules, even after marveling at their elegance and consistency, there is a final layer that challenges the way we think about reality. The more we study the cosmos, the more we realize that the rules are not just boundaries, they are possibilities. They define what can happen, not just what cannot. Gravity doesn't just pull, it shapes galaxies, bends light, and sets the rhythm of planetary orbits. Quantum mechanics doesn't just constrain particles, it allows atoms, chemistry, and ultimately life itself to exist. The unbreakable rules are, paradoxically, what make creativity and complexity possible. They are not limitations in a negative sense, they are the framework for everything. Without them, nothing could hold together, nothing could persist, and nothing could even begin. Thinking this way changes our perspective on randomness and uncertainty. At first, quantum uncertainty seems like a flaw in reality, a place where the rules break down, but it doesn't. Particles do not fail to follow the laws. They obey them in a way that only appears mysterious to our human intuition. Probability itself is a rule, a framework for understanding what might happen within a consistent system. It is the language the universe uses at the smallest scales, and it is precise, predictable, and reproducible. The apparent randomness is not chaos, it is structure at a level that our minds need help to perceive. This reminds us that not everything meaningful is visible to our senses, and not everything intuitive is correct. Understanding the rules requires patience, measurement, and humility. The universe also teaches us about scale and perspective. What is overwhelming at one level can be orderly at another. The vastness of the cosmos can seem infinite and unknowable, yet it is governed by the same principles that control the movement of your hand or the fall of a leaf. The smallest fluctuations in a quantum field follow the same logic that guides stars across galaxies. Recognizing this unity changes how we see connections. Everything, from particles to planets, is part of a coherent system. The rules are universal, and their consistency across scales allows life, intelligence, and curiosity to emerge. We are not separate from these laws. We are a product of them, capable of observing them, and in some ways, reflecting them. There is also a quiet lesson in accepting limits. Humans naturally want to explain everything to find the ultimate why behind every rule. But the universe may never answer that question. We can know how the rules operate, predict their outcomes, and test their consequences, but the deeper reason for their existence might remain forever beyond reach. This is not failure or deficiency. It is simply part of reality. There is beauty in that acceptance. The universe's vast rules are absolute, and our understanding, while remarkable, is always part of a larger story. Finally, seeing the universe this way changes how we live in it. The unbreakable rules are not constraints to rebel against. They are the foundation of wonder, discovery, and possibility. By studying them, we engage in a dialogue with reality itself. We learn humility, curiosity, and patience. We come to understand that mystery is not something to fear, but something to embrace. Every star, every particle, every interaction is part of a magnificent tapestry woven from laws that cannot be broken. And in that recognition, reality becomes not only knowable, but profoundly meaningful in a way that is entirely scientific. The universe is structured, eternal, and alive with possibility, and we, for a fleeting moment, are capable of seeing it clearly.